Un, deux, un, deux. Does it work? Hello everyone. Happy to see you again this year. For the ones that does not know me, my name is Jérémy Lagarrigue. I am the president of the jury, but also head of the technical committee. And as you know, for me, the tech talks are very important because that's the time where we can all share the developments that we have done, because we will be all smarter together than just on our side. And it is very important for us that you share all your development with all the other team in order to increase the level of this event for the coming years. As you see, I am Swiss, so I just start on time, and I will be ask you to do exactly the same, because we have a lot of people that need to pass after you, and that's the first year where we have this place, because the event is growing year after year. And at any before and after any presentation, I will ask the next team to come and join the tech talks. In front of you, you have 12 people from the jury, which are coming from the yachting industry, which are coming from the energy industry, which are coming from Natural Resource Foundation, and all of them have huge experience in the sustainable yachting. And I guess they are here to give you some graduation in order to win some good prize, and sometime also with some prize, financial prize at the end of the event. So the idea of the Tech Talks and the Tech Talks graduation, it's based on the quality about the talk, the quality of the speaker, the fluidity, the quality of the answer on the question, that because we can have the question coming from the audience, but also for the opening, like the open source spirit and open source ideas. I guess now it's your turn to speak and to share what you have developed with your team. At first, I really want to say to all of you, congratulations for what you achieved so far. And thank you for being here. And I hope that you will be very proud about what you can share with us. So the first team to join the stage is a team from the Solar class, it's HVHL IRS. Please join the stage. They let you down. So this is for you. Check if it's working. So you know the rules. You have 5 minutes, and we can start when you want.
So, is it working? Hello, hello. Okay, welcome everybody to our tech talk. I'm Anne-Frank Joustra and I'm a team member of HVHL Eres, which is in the Netherlands. So I hope after this presentation I gave you more insight about our team and about our ideas and where we're working on. So we are the Solobo team from Van der Ladenstein and Eres College in Leeuwarden. And Leeuwarden is actually the capital of the Frisian of the province Friesland. And Friesland is known about all the waters and the lakes. So therefore we can sail on various lakes in the Netherlands. So we're happy with that. And the HVHL Eres is a cooperation between two schools. The first one is a University of Applied Sciences, and the second one is the secondary vocational education. And we are in total with 11 team members, and now we are with 6 of them in Monaco. First of all, our team manager, Sam van Wijgaarden, she is studying chemistry. We have several students in the team, but also, we have some old team members who are already working. Our communication manager is called Katinka Benders, and she is working as a bus driver. Rex van Deursen is student coastal and marine management, and he is our electrical engineer. Then we have Peter Wiersma. He is our first pilot, and he studied chemical engineering, and he is now working in the Water Authority of Groningen as an engineer. Then we have Timo Kooijman. He is not actually part of the team, but he is our ad interim, and he is working as a mechanic in a technical center in the Netherlands. And yeah, I just graduated 2 weeks ago, chemical engineering and environmental sciences, and I'm here mostly for the social media. So that's a bit of intro about the team. So yeah, we started actually in 2008 as a project from school, and here left on the bottom you can see our first boat, and our first boat is made of cork, and it was an old catamaran, and it was a very heavy boat and not a very fast boat. So then through the years on we developed several boats. Now we have the Cinestream, and the Cinestream is made of a biocomposite, so it's not made of carbon. And we made our boat, our main component of our boat is wood, balsa wood, and it is make it stronger with flex fibers and aramide fibers. So that is our material from our boat. And actually we have a 7 kilowatt motor and then a lithium-ion battery with a capacity of 1500 watts. So actually where we're working on at the moment is our hydrofoils. Unfortunately, we cannot sail on them because we have several challenges and we need to solve them first. But mainly we have a V-foil in the front and a T-foil in the back. And the V-foil we have from another team which is called Dutch Solo Boat Team. And our V-foil is actually basically consisted about 3 foils, and we made them they made from carbon. And we made, in the bottom you can see a 120 angle, and in the back we have a T-foil, and which is also made of carbon fiber. Yeah, how did we make this actually? Yeah, we made the foils with carbon, and we made struts. And with the struts we connected actually the foils with that, and through press lamination we connected the struts to the foils. But yeah, we have some problems, I told you, so we cannot sail at the moment on the hydrofoils because the boat could not handle the press of the boat. So our hull actually broke a bit in the middle. So we fixed it again with carbon, and also it's very hard for us to sail stable. So we have a control system in our boat, and it's based on the height on the boat and the difference between the boat and the water, which allows us to sail stable. But at the moment, it's not really optimizing. So we need to work on that. And we did so far we did some testing on the foils. You see the picture left. We had some problems with our engine. So with a tow boat, we moved the boat forward, but it was not very stable, and due to the weather conditions, our top speed was 17 kilometers an hour. But the foils, we changed the position using an electric motor. So that's one thing we are very proud of. So we can change actually the position of the foils automatically. And we did also a lot of testing on composite materials. Here you see on the right-hand side, you can see a table with a lot of materials. And we are trying to find the best suitable material for our foils, because now they're made of carbon. But we want to see if we can also make them from other materials. You can see we tested carbon, glass fiber, and aramide fibers. But later on, we also found basalt fibers. Yeah, so we also found basalt fibers, and that's a very promising fiber. And we also made the solar panels in the back. They're connected to a basalt fiber surface. So we're really looking into that one. So, and this actually brings me to the end of my presentation. I hope I give you more insight about the team. And if there are any questions, let me know.
Thank you. And congratulations to be the first of doing the tech talks. Do we have some questions in the stage? It was clear enough for you? So thank you so much. We will continue.
Yes, thank you for your attention.
So the second team to join the stage, it's based on the energy class. Can we have please on stage Kaiman Ensta? Parfait. Vous avez la télécommande. Vous pouvez passer. C'est à vous.
Well, hello. So we're the Cayman Insta team from Insta Paris, which is a engineering school near Paris. It's actually the oldest engineering school of France that builds boats at the beginning of its history. That's why we're here. It's the second time we do the challenge. Here's our team. Yes, so this is last year's boat, and we made some improvements. So we put a solar panel on the front, and we built our own direction system.
Yeah, so our boat is divided in 3 parts. So the first part, which is the biggest one, is the mechanic part. In the first place, we used SolidWorks to design all the boat, and after that, there is the electronic parts. So with devices from the trade, and the last one is computer science. And we used an Arduino to do all the code in C. And with this code, we can control the speed, the temperature, and the velocity.
So for the structure, we used aluminum profilé to because it was cheap and easy to do, and we also use a 3D printer for some pieces of the thruster, and laser cut for the wooden part.
So we tried to use the recycled parts, so from last year's boat, or to buy parts of other boats that of teams. For example, the battery is from the Estaca team, and we try to reduce our buying of new stuff.
One innovative part of our boat is an application that the drivers use to get information from the battery directly in front of him. So he gets the speed, the temperature, and the intensity and the voltage of the battery and the control part of the battery. And he can then communicate this information to his partners on land.
So to conclude, the main innovative parts of our boat is the direction that we entirely design and build part by part, and this application that calculates everything and controls everything. Thank you for your attention.
Thank you. Do we have some question on the stage? On the jury side? I just have one question which I really want to focus. Thank you so much for trying to recycle some parts about the previous year. Does it limit you in the performance of your boat this year? And had you had this discussion in between buying new parts and recycling old parts? You decide the performance or the budget? What was the main reason about your decision?
It was mainly a matter of the budget, because we have not that much the budget to do this challenge. So it was for the environment and not really, and the budget, but not really for the performance.
Thank you. Can you share us your budget, please?
It was 5,000 euros.
Okay. With the transportation up to here?
No.
Okay, just to build the boat.
Yes, just to build the boat.
Perfect. Thank you so much.
Thank you.
So can we please now on stage the number 3? It's a solar boat and the name is AGH Solar Boat. Please on stage. AGH Solar Boat.
Thank you.
You have the remote?
Yep.
And I give you the time limit if needed.
Hello, everyone. So we're AGH Solar Boat from Poland. This is our flag, not Monaco. And yeah, we're from AGH from Krakow in Poland. More about that. Yeah, Poland is a country located in Central Europe. And AGH has been for many years one of the best universities in Poland. And they've enabled us, a group of around 80 engineers, 60 at the moment, but most of the time it's around 80, to build solar boats and raise them here in Monaco. And this is our current team, but yeah, I hope it's visible. I'll just skip over that. Okay. Ideas and inspirations. So here are some of the most interesting parameters about our boat Celka. And on the left picture is this one, the current boat that's with us here in Monaco. And on the right is the boat that it's sort of inspired by. It's our first boat that we've ever built, Baśka. And the idea behind Celka was to improve on things that we haven't done correctly when building Baśka. So, for example, we had 3 hydrofoils instead of 2, which gives us more stability and control over during flight and during foiling. Conception, methods, design. Okay, so we make heavy use of CFD simulations and FEA simulations, as shown here. Here are some of the results from our CFD simulations for the hydrofoil and the nacelle. So flow around these 3D objects. This is just a 2D slice, but it works for 3D also. And yeah, we also happened to create a mathematical model for our boat, just to develop the algorithm for controlling the hydrofoils during flight and during sort of ascent. And this year we've also designed, it hasn't been implemented yet, but we have a design for the new hydrofoil system because our last one didn't really do a good job. Okay. So the materials used in the production of the boat, which was actually started like 3 years ago and we finished it last year, is mainly carbon fiber with aramid honeycomb and epoxy resin. But then there's also some glass fiber and aluminum and steel, mostly for the drivetrain and mechanical parts, and obviously electronics. Yeah, this year we've faced a couple of problems. The main one being the relocation of our workshop, as shown on the picture on the bottom. Our old one was destroyed by the university for some new building they're putting up right now. And also everyone, I'm sure, has been really hit by the semiconductor shortages, with yeah, and that's a big hit for electronics. Also, there's still some COVID in Poland, and as we said, not real proper machining equipment due to the workshop relocation. Okay, for our testing, yeah, we also use CFD to validate our designs. Well, or rather, we validate our results afterwards when testing on water, and when we see if everything's all right, if it works as it should, as it was simulated before. So our results just showed that simulations were pretty decent, pretty realistic. We've determined failure criteria for our parts, which are supposed to like never happen. They're very overestimated in the simulations, and we've optimized our parts to be really robust. And we've come to an interesting conclusion that usually when the correct application of the joint is used, then usually the joint is stronger than the core material, so we won't have any breakage on joints, just material breaks. Okay, as for the life cycle assessment, so this is like a eco-friendly topic, as will be the next slide. So we try to do everything eco-friendly if possible. So every hydrofoil can be used on another boat that's compatible in terms of the mounting point, which we try to do with our boats as much as possible. And then also the solar panels, which it's a very tedious and difficult process, but they can have their individual cells replaced in the whole panel, which also extends the life cycle of the panel. And as said here, glass fiber and carbon fiber, after they've been used to, for example, build the hull or the hydrofoil, they can be reused as high-quality filler in industrial applications. Okay, more about the ecological design. The motor cooling system is built completely out of it was 3D printed, and then the water, it's taken from the body of water we're currently on. So in this case, the sea, and it's used for cooling. And the accumulator, so the battery box, is made of fiberglass that's been left over from the boat's construction. The new things that we brought this year with our boat is the new accumulator box, which has an unusual shape, and it's allowed us to save a bit of space inside the electrical box. Yeah, and as I said before, it's designed from leftovers, so it's pretty eco-friendly. And then we have a new steering system, which supports a steering wheel, just like on the render here on the bottom right. It's a bit easier to use for our driver, and it's also much smoother than the previous implementation, which was like a yoke drive. Okay, as for the industrialization of the project, we mainly focus on getting as much knowledge as we can out of building these boats. So our value really lies within the people. We have many people that are currently in the industry working as consultants in different areas, but mostly very I guess, educated people in composite materials, also software engineering, electrical. And yeah, coming out of our project, you can really find a job, no problem. So I suppose that's one way of using our project in the industry. And then we also have an idea around about building like end-to-end solutions with solar boats or just composite boats, because we have a lot of know-how in this area. Okay, thank you for your attention.
Thank you.
Have any questions?
Do we have some question? Okay, I do have one for you, because you just said that you build now the new battery this year. Could you explain us a bit more in details what kind of a battery management system you designed? Was it an in-house designed battery management system, or did you buy one that was already existing? What was the process about developing this new battery?
Okay, so we have the same battery management system, I believe, as last year. I'm not responsible for that part, so I'm not 100% certain. But and it's built in-house, as like 90% of the things on our boat. So I think it's like 12 cells in series construction, and we just buy the individual cells, then put them together by ourselves. And this battery pack has a rhomboid shape, so it's more packed in a way, and then which does have some problems with like cooling and airflow, but we figured it's enough, and it's more condensed in one place, which saves a bit of space inside the electrical box. And yeah, it's all custom designed.
And one other topic, you say that you monitor the mathematical calculation about the flight stability about your boat, because you design your foils and you try to implement a mathematical model in order to control the flight stability. Does it work very well? And are you facing some issue with the waves here in Monaco?
So we haven't brought it here to Monaco. Actually, one of the problems is the waves. But the second problem was that the old implementation used a control mechanism that was too slow to actuate. We didn't have enough speed to really control the roll and pitch and such. So it was pretty useless, actually. So now we've come up with a new design, which we're going to implement, but we didn't have time to do this for this competition, and we plan on doing this for the competition in Germany at the beginning of September or near end of June.
Perfect. Thank you so much.
Thank you very much.
So we will continue now. Can we please have on stage a team coming from Energy class, RIT Dubai Sailing Tigers. Please come on stage. With 2 engines. So there, and here we have the TV, so you can watch here. You are not obliged to watch behind.
Thank you.
Thank you.
Assalamu alaikum and bonjour. All the way from the land of beauty, culture, and diversity, we are Team Sailing Tigers, and we're here to represent not only the UAE but the Middle East. If you look behind me, you can see a picture of us where we got a glimpse of this beautiful country in Expo 2020. We even got to present our innovation there, and it was truly a great experience, but we're really happy to physically be here today. If you go to Dubai, you might see a small building called the Burj Khalifa. You have to visit it, it's wonderful, and if you go there, you see that it's a diverse place filled with people from different cultures, which is the same, which can be seen in our team members. We are comprised of over 10 different nationalities with all different multidisciplinary background. Coming together, we're here to create the Sailing Tigers team. Okay, so this year, to start up with the main components of our boat, due to the change in the rules, we have decided to increase our energy capacity on board. So instead of 1 lithium-ion batteries, we have 2, each with a 5 kilowatt-hour capacity. In addition, we are reusing last year's 6 kilowatt motor from ePropulsion. However, we decided to purchase a new motor that has a capacity of 15 kilowatt. The top of the boat will be covered with flexible solar panels that will generate energy throughout the races. Now, if you look at the center of the picture behind me, you can see a map with different shippings from one place to another. Our goal is to eradicate that. And you're probably wondering, with the portable frame, that's what we're planning to do. But you're probably all wondering now, how are we going to do that?
How? Well, I'll tell you how. Imagine you want to ship your boat from here, Monaco, to the UAE, but then you realize the hassle of shipment, the time-consuming process, and how long of logistics it would take. We are here to give you the new innovation that we are getting out after we have seen the last year's team suffer with the shipment. We are here to introduce to you the dismantleable boat. How? You can literally dismantle the boat, put it in your carry-on, and just take it on the go. The way we did it, we have 55 connectors and 88 adapters. And the concept started with SolidWorks design, each being rejected by our mentor, to next reach to the mathematical modeling, and that would give us a crucial data that the team would need to anticipate the races and how the behavior would go. With that, we didn't stop. We did ANSYS simulation, where we were able to find the stress points on the frame and the hulls, also the propeller. We have experimental data, which will next to be used by the next team to customize whatever they want to customize in the boat. With that, we next moved on to by choosing our materials. The frame itself is made out of 3 different materials: stainless steel, mild steel, and aluminum, all combined together to make up the frame. And these were used to use the pipe fitters, the tubes itself, and the metal plate at the back to hold the motor. The project itself was, it took us 9 months to finish and costed us about 21,000 dollars. And as the beautiful streets of Monaco, our journey was not straight. We had issues with the adapters where they were not compliant with the pipes that we had, so we had to modify them to fit the pipes that we already had at the workshop. Also, the center of gravity was another issue, and because of that, we were able to come up with the idea of having a movable IP box to adjust the center of gravity whenever we need. Also the drag, and that's why we came up with the idea of having a movable motor plate at the back, so that would help us reduce and minimize the drag. And the symmetry was no longer an issue after having a adjustable boat. With that, we went into lake testing, and we have 3 official lake tests next to the lake next to our university. First lake test focused on the power configuration and the maximum speed that we can reach to, and the center of gravity. Lake test 2 focused on the telemetry system and if we had any issues over that. Lake test number 3 just was on overall to see if everything is perfectly fine. And with that, we had 2 unofficial tests just to see how long will the motor, the battery will last. With that, we were able to next do the life cycle assessment, and that was done using Sustainable Minds software. And as you can see, it added up to a total of 5,800 carbon dioxide equivalent kilogram per function unit. And that was mainly due to the aircraft free, which was expected because of the long distance. And next also we had to figure out, we were able to calculate the millipoints, and that's the annual share of our project. And to the most important part, the eco-design. As the UAE is always pushing us, and this competition is pushing us towards sustainability, we were able to reuse some of the old boat parts and equipments, such as the aluminum tubes from there, and integrated into our parts to reuse whatever we had, and equipment such as the steering system and the seat itself. Also, the motor plate being adjustable helped us to reduce the room of error, and that would mean we did not have to remanufacture if we had any problem with the center of gravity. And also, fun fact, if you go to our boats, you will see the UAE flag, which did not get shipped with some of our equipment. And we just took a tow bag, colored it, and if you want to see our coloring skill, just pass by and check the flag. And yeah.
So to sum up quickly our innovations, firstly, we have the adjustable motor plate, like you mentioned. Each motor has a optimal depth. So if we get a new motor and the depth doesn't work, you can just adjust it to different heights. Next, the dismantleable frame. The frame is great. It's a build-it-yourself kind of frame, just like things you buy from IKEA and assemble at your own home. And if you look behind me, this is a volume of the frame in a enclosed box. And finally, our trimetry system that gives us data and information about things that are happening with the pilot when he's driving. This is just on my background, a block diagram of our telemetry system with a schematic and some results that we got during the testing back home. And now finally, for the industrialization of this project. Take a minute to think of the past. If you think of phones, back then, the two words that come to mind are bulky and stationary. You think of computers, they used to fill up an entire room at some point. Now, our phones are glued to the palm of our hands and our laptops are between our arms. Why can't we do the same with boats? Imagine just putting your boat frame in a carry-on bag. We, as Team Sailing Tiger, are thinking of the future and what it looks like, and we are ready to change the world. But the real question is the world ready for us? Thank you. Next slide.
Beautiful, congratulations. Thank you. Is someone ready for the question?
Yeah, so I was wondering, if you had no limitations in your budget, what would you like to investigate more? If you had no limitations in your budget, what would you want to investigate more?
Different material, definitely we would like, because our boat is a bit heavy, so if we could use a different material like carbon fiber, that would be great. It would make it much lighter and probably much faster as well.
I was just wondering, if you take the boat apart and assemble it here on the dock, how are you dealing with vibrations in the boat?
With what?
With the vibrations that are coming into the boat with
vibrations,
sailing.
Yeah. The adapters themselves are union adapters, and they're welded into the tube, onto the tubes themselves. We did it and we took it out. Again, they're back at our university, and vibrations are sturdy because it's made of mild steel and the adapters are themselves stainless steel. So it's sturdy.
Thank you. Another question? The same? Perfect. So congratulations. That was a very, very good presentation. Sorry. Sorry, Florestan, I didn't see it.
No, just on the dismantle frame, have you looked into potential applications for any boat that would be in the industry? You say that you have this vision, so this vision has to be further than the already mountain pads and that you have here, and you have a weight that is relatively low. So have you looked into how would it be usable, makeable for let's say a regular small tender or a regular boat that could be in the industry? Yeah.
Honestly, the main inspiration out of the dismantable was the shipment last year and how much they had to pay for the volume that they were shipping. So this is the first instance that came to our professor, and he was like, you have to make a dismantable boat. This is how we started it. But making it onto a bigger scale, we did not explore that yet, but we're assuming that with such sturdy material, and if we added more trusses, it should be able, obviously with more research, it can be something that can be done.
Thank you so much. Another time, congratulations. That's a beautiful example that we need to give the trust to ladies, and especially for foreign countries. Could you please now have on stage the number 5 of today? It will be an energy class boat. It's Uniboat. You know the rules, you have 5 minutes, and this is the script.
screen so you can watch here and not watching on the back. Thank you.
I don't think it's working.
It's easy. It's okay.
Hello everyone, we are Uniboat, the Argonauts team from the University of Bologna, heart of the extraordinary Italian automotive sector. We are a team of 30 bachelor and master students working together to transfer automotive technologies to the sustainable marine sector. Our 2022 prototype, Futura, features a self-built propulsion control system, 2 electric motors with self-built power electronics, a fuel cell system, 2 lithium self-built batteries, solar panels, and also some eco-friendly materials and an autonomous route assistant. The concept behind our powertrain system is for a fuel cell and solar panels to recharge the pre-charged batteries, which power the inverters, which are self-built, which activate the motors, which drive the propellers. We have a main control unit, which is connected to all components by a CAN bus system. This year, we decided to optimize almost every component of our boat. As you can see, we decided to build DC-DC boards for our fuel cell. We decided to implement a double motor configuration. We added another battery, we restructured our cockpit with a new seat, and we 3D printed custom propellers. The 6-month period production with a 30,000 euro budget, which we had to efficiently manage among the different division teams, required the use and mechanical expertise of different materials. We resorted to 3D printing for our custom propellers. We used recycled carbon fiber for the cockpit. We used bamboo canes for the solar panel frame. And we even used a byproduct of orange and cacti fiber for the cushions of our seat. The production wasn't exempt from problems, many of which arose during testing. First of all, we had to face the troublesome integration between 10 independent embedded devices, as well as the electrical and mechanical coordination between our 2 motors. Another big issue we faced was the tuning and fixing of the algorithms while at sea. We were often, in fact, on another boat connected to Futura with cables directly to the motors. The new lightweight regulations forced us to creatively explore and implement different structural solutions for each component of our boat. Our testing sessions were in the lab well, in the lab pool, and of course at sea. And thanks to our telemetry system, we were able to capture many variables. As you can see, we measured the speed, current, power requested by our motors, as well as other variables for our batteries, for example. The continuous need to, analyzing the data log was a crucial step in the algorithm tuning. The testing sessions allowed us to verify the improvement of performance with the 2-motor configuration. We also verified the increase in reliability thanks to the DC-DC boards in our fuel cell, and we experienced a 15% reduction of distance traveled towards a set target thanks to our autonomous route assistant.
Hi everyone. Talking about life cycle assessment, this year we performed an assessment on carbon dioxide emission saving. Regarding the boat usage, if we compare an internal combustion engine with our hybrid electric powertrain solution, we are able to save more than 30% of carbon dioxide during an endurance race. Regarding the boat production, this year we used several different materials like bamboo, orange leather, recycled carbon fiber scraps, and also recycled aluminum. And with all these materials, we are able to save more than 360 kilograms of carbon dioxide. Going deeper with some materials, bamboo is a valid alternative solution to aluminum, and we exposed the material itself to an open flame in order to increase its mechanical properties. Regarding carbon fiber, we use a method that gives a second life to carbon fiber prepreg scraps, and one purpose of it is the production of a positive carbon dioxide emission balance. Talking about many innovative features, the first one is the implementation of 2 motors, also because this year the total energy available on board has been doubled respect last year. Each motor has its own dynamic profile, its own inverter, and they rotate in opposite direction. In addition, we implemented also a differential electric control to make the curve narrower, for example, during a championship race or a slalom race. The second main innovative feature is the fuel cell, the realization of a custom fuel cell controller and a custom DC-DC converter. The DC-DC converter allows the fuel cell to recharge our batteries, and it switches at higher frequency in order to have a lightweight component. The fuel cell controller allows us to have an efficiency of 48% due to less loss in the components. The last but not least innovative feature is the implementation of route assistance algorithm. It suggests the azimuth of the shortest route possible in order to reach a target like a buoy, and it provides this information to automatic rudder, and thanks to its own controller implemented by the team member, the automatic rudder starts to steer. In addition, also this year, we decided to share with other teams this algorithm because we believe in the philosophy to share the information and grow up together. Regarding the industrialization of the project, we have in our boat a lot of redundancies because we think that it's a key concept in order to attain reliability. Regarding the efficiency gain, we have, with, for example, lightweight component, but also the route assistance algorithm, we increase our efficiency from several points of view. We have a custom electronic board and other custom parts, but also some standard components like transducers that are already available on the market, and thanks to it, our prototype is really closer to an industrial project. Lastly, we made a cost-benefit analysis, and we compare our solution to a boat with a gasoline engine, and we are able to save more or less 2 years during an endurance race. Just to conclude, and also this year, we decided to implement a mixed source energy solution because we think that it is the right solution in order to have good performance in terms of durability, but also in terms of max power, max velocity. I conclude.
Thank you. Do we have some questions?
Yes, what material did you use to hold the bamboo sticks together?
What? Sorry?
To hold the bamboo sticks, the kind of joints that you made.
Okay, so for the bamboo canes themselves, we used hemp thread. So we obviously keep in mind the sustainable feature of this whole competition. So just hemp thread to tie them, and then strings to have them not move, and then the bamboo canes themselves for the solar panels.
Kind of piggybacking on that, I just wanted you to give more details on because you use quite different types of raw materials. So the linen fiber, on which parts did you use that? I'm also interested to know, like you mentioned recycled carbon fiber. How was that recycled?
It is we use recycled carbon fiber in, for example, outer panels of the deck of the cockpit, but also, for example, in the anti-ventilation plate, and and also some, for example, part that divide the pilot with the fuel cell. and it is recycled because we have scraps that usually the scraps are disposed of, and usually we take the new one. But instead, we decided to connect the scraps together and make a final piece.
So how did you connect the scraps?
There is a specific method. Also, after we have, for example, we start to make, to connect each other and start to make one layer, and then we put inside the oven in order to cure the material itself, and then it's finished. It's very strong. But if you want more details, I can pass the microphone to the person who deal with this solution. No problem.
A question about the weight.
Yeah.
Have you considered the boat that you had last year, the boat of this year? There is a big difference in weight or not? You are going to a double motor instead of a single motor. Since you are in the water, and one way or another you are displacing water, and consequently the weight is playing a role. Have you considered also to put on board maybe some very light pilot or not?
No, okay. Yes, we take in consideration, of course, the weight. In fact, we have double boat. We have a lot of, as I said, redundancies. So 2 batteries, 2 motors. So we increase the weight a lot. And in general, yes, we decided to substitute some materials, like from the structure of panel, from aluminum to bamboo, and also the cockpit from steel to aluminum. And with this solution, we try to respect also the rule of the total weight also.
A question about material. In which material are you making your propeller? To designing your propeller, you make your 3D printer. You told that you made with 3D printer. And in which material are you making the propeller?
In which, sorry, material?
Material.
Material, the propeller?
The propeller, yeah.
With nylon. We realized the custom propeller with a specific study about it. And we designed the 3D design. And we implement this, we realize it in the nylon material.
And I have another question. I'm sorry, but you know I really push the open source. I know you have a specific battery with a very high power density. Congratulations, by the way, for the open source about this automatic drive that you are offering to the other team. I guess that might be smart, especially for the long distance race. But could you please share with us a bit more details about the battery you are using?
Yes, we have, yes, these are 2 packs of 3,000 watt-hour. And so we have 2 for a total of more or less a little bit more, 6,000 watt-hour. And they are with the Lion cell. And we have, if you want the characteristics of the packs, I can give you. So we have 21 in series and 14 in parallel cells, VT6 cells. And this is our pack. We realized that 2 years ago, also with the help of a spin-off of university, and that's.
Thank you so much. Congratulations.
Thank you very much.
So very happy to see that the open source is growing and growing. So now can we please have on stage the number 6 of today? It's still an energy class. Can we have on stage Exocet, please? From Canada, no? That's the first time that you are participating.
Hello everyone, I hope you're doing well. So we're Team Exocet from Canada. My name is Mathieu. Olivier. And we're from Polytechnique Montreal, so in Quebec City. We're French speakers. So about the country, it's big. It's the second biggest country in the world, so it's almost 10 million kilometers square. Next, it's got a big range of temperatures, so from minus 40 degrees Celsius to plus minus 40 to plus 40 degrees Celsius. So it's a big range of temperature, and most of the year the water is frozen. So for a boat, it's not ideal. The university is here since 1873, and we have almost 10,000 students. And for the team, it's a project that began in 2020, and we have almost 15 members right now. So it's the first time in Monaco. We are really grateful to be there. This is the team members. Next. For the inspiration, the boat, first, the cockpit was inspired by old F1 cars, so we can see a little bit by the shape, but mostly the structure was inspired by ultralight aircrafts. Most of the team is from an aircraft background. So it's an aluminum framing with ultralight clothing that shrinks with heat around it. So it keeps the shape really well, and it's really rigid. And we use a Torqeedo Cruise motor. So for the framing, we use the 4-section of aluminum tube framing. So basically, the boat can be shipped and dismantled in 4 parts, and we can put them like in another orientation to have a really, really small volume, so it can be shipped really easily. And the boat has around 200 newtons of drag and 800 newton of static thrust. The motor efficiency is of about 56%, and the maximum discharge of the motor is 8.8 kilowatts. For the materials, as I said earlier, we use an aluminum structure with a heat shrinking and water resistant clothing. We also use a lot of high density foam for things such as the seat and the headrest, and we use the wood for things like the floor and the motor mount. The wood, however, is really hard to ship by aircraft because of the regulations, so we had a few problems with that. So speaking of problems, first of all, we need to ship the boat from Canada. It's a big flight. We also have to ship. Initially, we looked at shipping the battery, but it was way too expensive to ship lithium-ion cells by aircraft. So we instead choose to have 2 batteries. We build our own battery in Canada, and we have our second battery, Torqeedo battery, here in Monaco. Also, because of the pandemic, and we started the project during the pandemic, we had a lot of difficulty finding team members. So we're really grateful for the team members we have. And as I said, water is frozen most of the year, so testing is not something that is quite easy in Canada. The project took about a year to build and is about 10,000 euros. That being said, about 40% of the project was only for the shipping of the boat to Monaco. So we still managed to do some testing a few weeks before shipping the boat. We had a partnership with Lac des Deux Montagnes sailing team, and we used recycled Hobbycat 16 hulls that we modified to be a bit larger. However, the center of gravity was not the same, and the weight of the boat was not the same either. So we had to play with that because the Monaco hulls could not be shipped to Canada. And we also had a different battery, as I said, so the electrical specifications were a bit different.
All right, thank you, Mathieu. So for the life cycle assessment, actually we assessed it for the early life, so that's what we considered the construction of the boat. So we used some new materials, but the majority of all our materials and equipments were actually secondhand. So actually our motor and our battery are secondhand, as well as some wood that we reuse and metal parts. So the midlife, so when we're using the boat, what we actually use is just the electricity of the battery. So in Quebec as well, we have lots of hydroelectricity since we have lots of dams. So we have almost zero emissions during the consumption of our electricity. And for end life, what we're projecting to do with the boat, well, actually we want to do like a mock-up or a model for the future team members learn them, to give them information about the boat or do presentations. So that's what we're looking up to do. We will also be able to reuse materials since our boat is actually 4 parts. We can disassemble it, reuse the front part and change the back, or use the back part and change the front. So it's very modulable, very easy to change the structure. All right, so our eco design. So we did a lot of efforts in this. So actually our design is really around this part. So we have, first of all, we used a lot of recycled materials. So actually, fun fact, our pilot, the seat of the pilot is some reused foam. So the foam was from a group of students that was beside us, and they were scrapping it, and we took it, shaped it up, and made a nice seat for the pilot. There is also, since we can disassemble it, it will all fit in one little box, a wooden box. Since we had to ship it by plane, we really wanted to minimize the volume that we needed, since the environmental impact really goes up with the volume you take. So actually, when it's all unfolded, you can see at the top of the picture, the first picture, and once it's all fitted in, it will all fit inside this 1.5 meter cubic meter volume of a box, and it contains the frame, our tools, everything to build. So that's just the only thing we had for Monaco. As I said, our mainly innovation today was the part that we could take it apart, put it in a box, ship it by plane, very cost effective and eco-friendly for this part. Last of all, so industrialization. So what we did, we used some lightweight and rigid structure. This allowed us to have a lesser weight to ship by plane. So again, better for environment and cost. We also use corrosion-resistant materials such as aluminum. So we needed less maintenance, and also we did not need any chemicals to protect the metal inside our boat. Last thing, it's very modulable. So if something is broken or we need to repair anything, we can just take out the defecting piece, repair it, and put it right back, screw it back on, and we're ready to go. Thank you very much.
Thank you. Do we have some question? Yes, je reviens.
Hello, nice presentation. I heard that your frame consists of how they make planes with aluminum tubes or aluminum and also heat shrink around it, right?
I'm not sure I understood the question.
Oh, no, the question comes after that. So is that correct? Yes. How does the heat shrink hold up in the heat of here in Monaco?
Well, the heat, we use a heat gun, so it's made to shrink with a lot more heat. But once it's shrinked, it stays like that. So basically, we put sealant on it, and it seems to do a pretty good job.
Ah, great.
You said that the cloth around the whole frame was formed by heat. But if you take the frame out, does it need reforming or something?
Actually, we don't have to take out the heat shrinking cloth. We can take the front, swipe it around, and put it in the back, so we can mount them all together. But we don't have to take out the cloth to assemble all in the box.
Thank you very much for the nice presentation. You mentioned that you have 2 batteries, and I think that's a very interesting approach to solve that problem. So my question is, could you tell us a little bit more about the logistics and how you come up with the decision, and just tell us a little bit, how do you get to build 2 batteries in different continents?
So as you said, for sure, what we did is we checked the cost, and it was costly, too expensive. So what we did, we tried to find a partner over here that we could find a battery. So we were able to find a partner with Torqeedo that would lend us a battery for the competition. So this was our battery over here. And what we did in Canada, so we built a battery, and by ourselves we took the cells and we all put them together to build our battery. And we tried to match the specs of the battery that we have over here. So that's how we did the testing on the water, and we made our boat run.
Merci. Déjà, juste merci d'être venu depuis Québec, hein, pour avoir fait le voyage une bonne dizaine de fois. Thank you for coming all the way from there. And I'm just wondering, because we have to keep in mind that a lot of teams have a big history of building boats. They can carry on, which is great, huh, with past teams and past boats. I'm just wondering, what's the history for your university on boat building? Are you the first team? Are you close to be the first team? Just wondering.
Yeah, so we're the first team, but Mathieu was one of the main primal first that created the group, so I'll let him.
We're the first one to do a motorboat. We have like canoe teams, but we're really the first one to do that kind of project. Many of our members have external experiences. I personally worked in a marina for many years. We have also many people in the group that worked in that kind of project, but for the university, it's really new.
So that's great. So, you know, you're very important to keep on going and to get a lot of information from these guys, so you can come back and make sure you have much more teams coming after you in Quebec. So
that's
thank
what
you
we're
again.
trying to do. Thanks.
Thank you and congratulations. And just for you to know that we are working on having a partner that is able to finance the logistics. So I guess that will help all the teams. Thank you so much and congratulations. So we need to rush to respect the schedule. Can we please have on stage the number 7? It is a solar team and the name is Solar Boat 20. And we are used to have beautiful tech talks from your team, so you have a huge pressure. Huh?
Big pressure, big pressure.
This is, you know the rules, 5 minutes, you have the screen here.
So, the world is changing ever so fast, and the need for sustainable technology is becoming more clear and clear. As I might not need to tell you here, this is also the case in the maritime sector. So, what to do about it? Well, first of all, we would like to thank the organization and the Yacht Club of this event for the opportunity to actually change something, to do something about them and inspire you with our ideas. The goal of this presentation is to show you our greatest innovations of this year. We are actually very excited for this, as this is very close to our own philosophy. We'd like to come together with innovative minds to together share ideas and create a movement forward in the maritime sector. I hope you're all now wondering what kind of innovations I'm talking about. So let's get into it. We are a student team from Enschede in the Netherlands. Now a small question to the audience. Who of you all know Enschede? Raise of hands, please. Yeah. Big group there, some there. Thank you very much. Well, you might know us for our Twentse Ros, a big red horse, which is also in front of our boat. But, as you might not know, the University of Twente is actually the most entrepreneurial university from the Netherlands. I see people from Delft frowning a little bit. Are you sure? Yes, I am actually sure we are. And I think our team is a great example of that. 18 students who together took a year off to look towards the best and greatest innovations for our boat out there. And that year has led to Rising Trident, our current boat, a boat with a new modular driveline. 6 square meters of solar panels with a maximum efficiency of 24.8%, 3 hydrofoils in reverse canal configuration, and a counter-rotating propeller. Now, to inspire you the most, we want to dive into this last characteristic, the counter-rotating propeller. Now, why is that? That is because we think this characteristic stands for the way we look at sustainability and innovation at Solar Boat Twente. So, beginning of this year, we started the innovation of our counter-rotating propeller. It's a concept that has not yet been widely researched, but we think has a lot of potential. The idea of a counter-rotating propeller is that the front propeller counteracts the turbulence that the front propeller creates. We started with an open source code that was already there. It was actually created by our first ever solar boat team. It is a source code that with just a few characteristics designs a whole propeller for you. We improved on this script by adding X-foil. So X-foil will make the script more advanced when weighing the amount of drag versus lift you have in your propeller. After your design, of course, you have to come to production. Now, the method of production was a special one. So get ready for our second big innovation, because for the first time ever, we 3D printed our propellers. We 3D printed our propellers out of Inconel. This production method, as well as the material, has a few advantages. So, 3D printing is a quite sustainable process for producing our propeller in comparison to other production processes like casting and milling. It's also known as additive manufacturing, and it uses 98% less material than these other methods. Besides this, you are able to play with more complex shapes when 3D printing, and you are able to play more with your design. Inconel is a very strong metal. To demonstrate that, it's usually used in airplanes, so it's suitable for quite some extreme conditions. Innovation like this, of course, wouldn't be fun without a few challenges. So we'll come back to those challenges when we talk more about industrialization. Now, besides challenges and their solutions, testing is needed to get a better iteration of our propeller. We found out this year how important early testing is. So we test in and out of the water. Out of the water, we run computational fluid dynamics to get an indication of the efficiency of our propeller. Right now, the open water efficiency of our first iteration is 78.4%. We also do some in-the-water testing. We like to know how the power we put in relates to the speed that's coming out. We do this in our home waters at the famous Canal of Twente, and we also like to simulate some more Monaco-like scenarios on the Lake Kettle. So, how do we think our propeller is valid for racing? That you'll find out the coming few days. Do we think our propeller is fit for the industry? That I'll come back to in a bit. Now, after all this talk about the propeller, I wanted to talk about something I stated in the beginning. The propeller is something that is characteristics for the way we look at sustainability and innovation here in Twente. So why is that? That is because our other projects also have the same philosophy. It's one where innovation and enlarging the life cycle of our projects go hand in hand. We stated a few examples here. So for example, our new modular driveline, where it's very easy to get components out, optimize them, or even swap them. Also, we have a new modular solar panel system in which we can remove our solar panels, work on them, and also place them on our new boat. Besides enlarging the life cycle of these projects, we also like to think about eco-dimensions when thinking about our project. Now, the main object we were talking about, the propeller, it was produced inside the region of Twente, and we actually like to keep a lot of our partners close. Half of our partners are inside the region of Twente. And lucky for us, as the Netherlands is quite a small country, other partners are always close. Making our project more ecological and more efficient doesn't end here. Next year, a fresh and new group of students will work on new projects with us to support them. Things they will tell you about in our next tech talk are our new gallium nitride transistors for in our motor controller, and or our electronic stable control system. But more about that next year, as we like to keep everybody a little bit excited for our projects. We want to close off this tech talk by answering the question I raised when talking about the main subject, the counter-rotating propeller. How can it actually help the industry? Because in the end, that's what we're all working towards, right? A better maritime sector. First of all, we would like to make our propeller software open source. This way, other companies and other teams can not only use it, but maybe even improve on it. Besides that, we think that 3D printing is a very promising production method for the sector. There are still a few challenges, however. One of them is that Inconel is a very rare and expensive material still. There is a solution though. That is the process of biomaterial printing. You print the inside of your propeller from a much less rare and less expensive material like stainless steel. You top that off with a layer of Inconel to care for the strength properties, and voila! You have a propeller that is suitable for the industry and very strong as well. Now, how to help the maritime sector improve and how to go for a more sustainable movement. We think we have made a good step here, and I'm sure of the fact, and I listened to you, everybody here made good steps. And that's what makes this challenge so beautiful, the fact that everybody likes to share their idea, and I think together we can propel forward and make the industry a better place. Now, in that light, I would like to hear all of your questions and suggestions to our talk. And for that, I would actually like to ask two of our other engineers to the stage who have more in-depth knowledge about the stuff just talked about. Thank you all very much for listening, and let's innovate together.
Thank you. So, do we have some question to 20 here? Two from the jury. Excuse me.
Thanks for the presentation. How do you think that the industrial process that you are using right now with a 3D printing metal is compliant with industrial production compared to the cost? Because I assume that one of your propeller right now is quite expensive.
Yeah, we do not exactly know how expensive it is. The company that we printed it at didn't want to, how do we say, didn't want to give the prices for us. So, and I think that we will respect that. But there are cheaper ways. I think that the Inconel choice of us was made by the company itself. They had for the first time a printer for Inconel, and they wanted to experiment with it. So in the future we are looking to more other materials, also light. We want to do maybe something with titanium, but I know for the maritime sector there is also printed with other materials, and that is done by the LAS method with more different materials like stainless steel and that kind of stuff.
Thank you. You answered my first question, which was why Inconel, because I couldn't understand why you would choose that material, really. My second question, what was it now? Oh, the counter-rotating propeller. So I suppose you've tested it, and it makes some physics sense, right? I mean, you could go there. But what about the testing and the... did you see any improvement in efficiency when you compared it to regular propeller, maybe from past teams? What are some of the numbers that you saw from it?
Yeah, well, funny that you ask that, because we see difference, but we're not there to show the numbers yet, because we had some different tests with an endurance test, and if we compare that to last year's, we could squeeze out more range than previous years. So that was good, but we lost the numbers of that year before. We only know that we came further, but not how much. So yeah, since we did not change the boat, we can see that we come further with this drivetrain, and we hope to see and to compare this year to last year, and we hope to even improve it further in the next coming years.
Yeah, just to an overall answer, we all know that by having a contra-rotative propeller, we can increase efficiency from 6 to 10%, but let's say the average is 8% efficiency that we increase, and especially another 4% if we have the propeller in front of the rudder. So I guess that's why most of the solar team use such solution, because they are quite well advanced, and I'm very looking forward to see the other class like Energy class and Open Sea class to use such solution. It might be an example for you to buy some engine from the solar team for the other teams. But Now, I was very concerned on the previous slide, maybe this one, about the overall efficiency. Could you please describe the efficiency calculations that you have done on your boat? And after, another question, I will finish about it because we will be struggling with the time, is on the previous year, you developed a specific foil that was, if I do remember correct, a sort of adaptive foil with a specific materials that was, it was a deformation. It was a link in between the two foils, the starboard one and the port one, and they together were attached with the specific materials. So could you also please with us this feedback, please?
Yeah, the first question was about overall efficiency, right? Yeah, well, first we calculated theoretically what comes out of our calculations, and that also depends on what we put in there and what we discard and what not. So our first calculations came up to 90% efficiency, which is ridiculous and not really comparable to what we see in the real world. So we also make a computed dynamic fluids to see what happens there, and then we saw already a drop in efficiency. And we are also testing in the water to see if we can, if we know the losses in our drivetrain in the motor, we can recalculate it and see what we estimate to be the efficiency in the real world. So we hope to see that it is really close to the CFD data. So yeah, and for the second question, I will give the mic to Jitse.
Yeah, so about the question about the flexible center wing, it's in fact 3 years ago we had the design. We did that to improve the roll stability, since our first design almost 6 years ago only had small flaps on the sides to stabilize the roll. So we thought, well, maybe we can have a flexible center. But in fact, we researched it at Marin in the Netherlands, a research institute, and we found out that it had more drag than it would improve our system. So we changed to the 3 wings we have right now, and later to a flap design, which is still on the boat. That was last year. Does that answer your question?
Yes.
Okay.
Thank you so much. And now is the best to conclude, I hope so. It will be a team from energy class. Can we have please on stage C. Sakti, if I pronounce it correctly, from India. Please come on stage. This is a remote. Here is the screen, and you have 5 minutes. Do your best. I am your first supporter.
Presenting here is a story, a short story of a young team all the way from India in a quaint but a hustling city called Coimbatore in the state of Tamil Nadu in India. Now I know it's very difficult to pronounce Coimbatore, so let's just stick with calling it the Manchester of South India. Despite coming from an oceanic country with a rich marine heritage and a culture so deeply associated and rooting with boats as well as yachting, we built our energy boat with little to no access to ocean body. We come from a landlocked area, so that means we need to travel a minimum of 4 hours to get to the nearest ocean body. Now, none of us need a tanning, but if we had to, we have to travel around 3 to 4 hours to get a pretty natural one. And until this competition, both of our pilots never swam in the ocean. So I'm pretty sure that the last time they were in the waters before this competition, they probably had rubber ducks probably around their waist. So that was pretty much the last time they were swimming around this ocean. So neither were we equipped with the best of marine infrastructure, nor do we have the proper background. So how do we get here? What is our story? And what set the inspiration? And what are our aspirations after this competition gets over? And why should you listen to our story? This is the reason why we're here. We're Team India, and we call ourselves Team C Shakti. I'm Sana, and joining me here is Mohan, Anjana, Bharat, as well as Leo. So India is a country with the largest shoreline in the Indian Ocean, and we are the only country to have an ocean named after us. We come from Kumaraguru College of Technology, which is one of the leading institutions in the state of Tamil Nadu. And we are Team C Shakti, who are 14 undergraduate students from various engineering backgrounds such as mechanical, mechatronics, electric, as well as computer science. Over to Mohan.
Hi. Shall I? Hello. Hi, this is Mohan. We are having an inspiration toward building automobile things. So with the inspiration of KCT's Formula student team, we built the whole boat. So initially we decided to build the boat as light as possible. So our boat has a primary energy source of battery pack with 48 volt, 9.6 kilowatt hour of ferrophosphate and battery pack. Then a secondary source of semi-flexible solar panels. So our boat is powered by, driven by 6 kilowatt of outboard motor. So moving to the conception method and designing. So we have made our whole cockpit out of aluminum 6 series material, and we designed the whole cockpit out of truss amplified one to withstand all the stresses and all. And our propulsion system is designed using Hydrodynamics B propeller series. So for designing and validation, we just used SolidWorks CAD software for visualization and 3D designing. And for ANSYS, to do a structural analysis and CFD analysis of the whole boat and the propeller.
Hey guys, actually the electrical system of the boat is powered by a 48 volt lithium ferrous phosphate battery, and we also have a secondary source which is a 200 volt mono PERC panel, and then it is also connected with a smart solar charger, which is MPPT, which is run by MPPT algorithm. And since it's a smart one, we can connect it to an Arduino or any other IoT devices, and the data can be read by the onshore team. To measure the battery parameters, we have connected a smart shunt, which is also by the same brand, Victron. And both of these devices will run with have a V-Direct protocol, so that the data can be transferred with the same serial data. And it is also connected to a self-developed custom dashboard, which the onshore team will be monitoring.
So moving on to the whole production of the boat. So we have started our boat production by February, and we have completed within 3 months. So it took about May to complete the whole boat production. So from material wise, we have made the cockpit out of aluminum 6063 T6 material, and we have made our own hull for our testing purpose. It is made up of FRP material, and there are 4 problems we have faced in India. Initially, the components availability like pod propulsion system and the availability of some electronic components like a 4G LTE module. So the overall budget is about 18,000 euros. Then the simulation testing and results. So we have tested our cockpit and ANSYS workbench. So we just consider the weight of battery and the propulsion system and the driver. So we have gone through a lot of iteration, and we came up with a better factor of safety frame. Then we just did safety analysis of our propeller under maximum RPM of the motor and the max speed. We have conducted 2 tests. Initially, we just did the buoyancy test since we have made our own hull out of FRP. So first we did the buoyancy test of our hull. Then we have tested our whole boat in port of Chennai. So with the spec of 48 volt, 9.6 kilowatt hour, the maximum we can reach up to 16 knots. And same, we have analyzed our solar panel, battery pack, and motor performance in that.
So actually we fetch data and store all the data to the real-time, we all fetch the real-time data and the GPS records, and we show the statistical analysis of the boat in the particular session of the boat which we are riding in the sea. And then we actually collect all the data, which is like the level of discharge of the battery, and it is shared to the pilot by the onshore team to the strategy planning. And we have self-developed the embedded systems and through a microcontroller, SkyLT module, and this is processed through the API link, and it is displayed in the dashboard, which is shown there. So a dashboard camera is fixed on the boat to live stream the boat view to the dashboard in the right side corner of the dashboard.
All right. Coming to the life cycle assessment of the project. So life cycle assessment is the effect that a product has on the environment throughout its entire life. So the life cycle assessment of the project has been divided into 3 parts. So first, these are the 3 prominent components of the project: the hull, the cockpit, and the internal components. So the hull, though being provided by the organization for the competition, we wish to develop it for the purpose of testing in our home waters before the competition. So the hull that we had developed is 55 kgs and is made up of FRP, fiber reinforced polymer. So the hull after the competition would be used for subsequent competitions in the next years, and it would also be used for similar projects, similar marine-oriented projects. So reusing the hull even after the competition would lead to reduction in CO2 emissions up to 514 kgs of CO2 equivalent. Indeed, quite high. And moving to the next prominent component of the project is the aluminum cockpit. So the cockpit is fabricated using aluminum 6 series, aluminum 6063T6. So the cockpit after the competition would be recycled, and aluminum is indeed known for its great capability of being recycled. I mean, 95% of the aluminum could be recycled. And the choice of aluminum over steel, steel, it is quite popular when it comes to the development of chassis. So we choose aluminum over steel because recycling aluminum after the competition would reduce CO2 emissions by 37% than that of steel. And recycling aluminum also has lesser acidification, eutrophication potential, and also has lesser potential to cause to create ozone layer. All right. Coming to the eco-design concept of the project. So to make it clear and understandable, we divide it into 3 parts. So first is the justification of choice of aluminum over steel. So the justification of choice of aluminum over steel can be justified in 2 aspects. One is the weight concept of it, weight and density concept of it, and the next one is the capability to be recycled. So aluminum is 25% less denser than steel. Steel is quite popular when it comes to the development of chassis. So so we did a comparative study between steel and aluminum, and aluminum is 25% lesser denser than steel, and lesser density has, it leads to lesser water displacement, and this has this leads to 20% reduction in energy consumption, and this again leads to lesser reduction in CO2 emissions by a figure of 17%. The next one is a choice of 3-blade propellers over the 5-blade propellers. So we use a 6 kilowatt propulsion system powered by Torqeedo 6.0 Cruise. So the 5-blade propellers, the specifications of the 5-blade propellers has been mentioned here. So we calculated the drag coefficient of 5-blade propellers and 3-blade propellers, and we found out that 3-blade propellers gave a drag reduction by 8%. So a lesser, a reduction in drag can lead to a reduction in energy consumption, and a reduction in energy consumption can lead to lesser CO2 emissions. And the next thing is modification of the chassis from Model 1 to Model 2. So if you look at the Model 1, you can see that the nose cone of the, the front part of the Model 1 has a rectangular kind of thing, rectangular nose cone, and the Model 2 has a curved nose cone. So this has been done after a lot of iterations and a lot of modifications to the chassis. So the second model showed a lesser, lesser drag and a higher speed. So again, lesser drag means lesser energy consumption and lesser CO2 emissions. And so, yeah. So industrialization of the project. So we come from India. So in India, the inland waterways make it up to 14,500 kilometers. And the GDP contribution of the inland, the marine sector is 4.1% of the total gross domestic product. And unfortunately, the greenhouse gas emissions from the inland waterways is about 22 billion kgs of CO2 equivalent per year. And so developing an electric boat from scratch may not be affordable for all. So we wish to develop an electric conversion kit which has the flexibility to be integrated to any kind of boat, any kind of small scale boat. So we retrofit any kind of boat, existing boats with IC engines with the electric conversion kit that we are making, and this paves the way for sustainability. And this electric conversion kit is aided by a solar panel, and it also comes with a special feature of, the onshore team would be able to monitor the moves, the conditions, and ensure the safety of the pilot. So we shall see about it in detail in the next slide.
So as I said before, we have a dashboard which is displayed here. So a special feature is that we are fixing the camera to monitor the pilot and the shore how the boat is going. And then our boat Yali sends the GPS data to the onshore team so that it is displayed in the map and it is tracked. And we are using these data to give the best performance of the boat in the next rides. And this part of the thing is sent to a third-party server, which provide us an API link, which is easier way to connect it with the front end.
Thank you. So to conclude with, maybe you've heard and maybe you haven't, but India is one of the youngest country in the whole world. This probably explains why we are the youngest Indian team here. 1 in every 6 person you probably meet would probably be an Indian. And personally speaking, I've lived in the Middle East for 19 years, and I can assure you that if you throw 6 stones up in the air, 4 would probably fall on Indians in Dubai or in United Arab Emirates. I believe the fellow competitor teams would probably be able to testify for it. And we come from the state of Tamil Nadu, where in Tamil Nadu has the highest renewable energy capacity. So out of our total electricity generation, around 40% of it is renewable, which is a huge number for a huge state like Tamil Nadu. India has a dynamic young working force who probably get into startup as soon as they graduate. So we are here in this prestigious Monaco Energy Boat Challenge so that you understand our capacity, you also believe in our potential and also invest in us. We are here today so that we are not only heard to, but also listened to at the end of this competition. Thank you very much.
Stay. Thank you and congratulations. Do we have some question?
Thank you, and same as for the Canadians. Thank you for coming, and for the United Emirates people coming all the way here. Thank you for that. 2 things, you barely mentioned it at the end, because you obviously one of the main things that you designed and developed was the dashboard and the microcontroller. So I was wondering. And at the end, you said we used a bit of the. I was wondering because you mentioned drag simulation, and simulation is good, but also you were able to test it, and I'm wondering how much did you use the numbers you had on the dashboard and on the controller? How much did you use that in order to improve the hull, in order to make your choices? That's my question A. And my question B is, you mentioned electric conversion kit. If I understood correctly, you have a Torqeedo motor. Most of what you have are things you got from outside. So what exactly you are providing when you talk about electric conversion kit? Is it just putting together different products and add in your dashboard? Did I miss something? Or what are you really providing when you're saying we're proposing an electric conversion kit for other boats in India and possibly elsewhere?
Yeah, sure. To answer your question, for the A, we are not displaying the data which you are showing. It is from the shunt, MPPT, and the GPS module which we are providing, which is satisfying the need for whatever it is displayed there. And to answer B, it can be modified. We are actually giving login credentials for our team itself, so that it can be modified to the other boards which whatever they told, and we can provide it to the customers or the users who can use it, so that login credentials will give their best result in their performance. Thank you.
Thank you. Do we have another question? I guess I have one. There is something for me that was a bit highlight, but not enough in my opinion. It was the amount of boats that you are having in India. I think that we are all here because we are all concerned about this energy transition, especially what we can do for the marine transition. And I think that if we can help a country like India to involve in such a revolution about this renewable solution, we need to do so. So I am one of your first supporters, and I hope that all the other team are supporting you in order to give you the best skills to improve a better boat and better future for the next generation. So thank you for what you achieved. Thank you for coming. And I hope that you have all the support for all the people here. Thank you. So that was the last team of today. I hope you have seen the difference in between marketing and techniques, and happy to see you tomorrow. I wish you a good opening ceremony and looking to see you tonight or maybe tomorrow. Thank you.